Hello everyone. Confirm for me if you can hear me well. Can you hear me? Just send a message in the chat if everything is fine, if the voice is clear, so we can start. All right. So we will start in 1 minute. Please let me know if you can see my IDE or you see something else, because I think there is an issue. So which screen do you see right now? All right, so maybe there is a problem. And what about now? Like, do you see now my IntelliJ? All right, perfect. Okay, so I guess we can start. So first of all, before we start diving into Spring Data JPA, the last time we saw that there is an issue with this, like with these lines of code. So like the problem was like this. So when I try to start the application or to run my application, we see that we have this issue right here, cannot find symbol method get games. And this is something related to Lombok with the latest version of Spring Boot. And the quick fix for that is here you can check the Lombok version, which is 1.18.36. So the problem is mainly with the Maven plugin right here. All right, so like it's for the annotation processor. So all you need to do is to add the version in here, because like I found out this bug like few days ago, and I'm not sure when it will be fixed. So first I will update my my Maven project, and now if we try to run the application, the error should be gone and the application should be started correctly. So like as you can see, now the application is starting up and everything is fine. So just again, the problem is mainly with Lombok, with the annotation processor for Lombok, and all you need to do is to add the version of the Lombok that you are using. And how you can get it here, just go to the Lombok dependency control and click on Lombok, and here you can see the version in the pom.xml file for Lombok. All right, all you need to do is to copy it and paste it in here in the plugins, and here you have the Maven compiler plugin, and you have configuration and annotation processor paths, and here and here in the path all you need to do is to add this version, and everything should be working fine. All right. So now with everything fixed, I guess we can now even update our Spring Boot version. So like our project is 3.4.1, and here let me make sure what is the recent version. So start.spring.io, it says 3.4.1. So we can also do an upgrade in here. And now all we need to do is to reload or to update our Maven dependency. So here, like, you will see this warning right here. So like for now we don't care about it. It will be fixed soon with the next release. All right, so today we will have a deep dive into Spring Data JPA. So we will start with like we'll start from scratch and explain what is Spring Data JPA, what are the advantages, what are the things that come with Spring Data JPA, and also like we will see a few interesting things about Spring Data JPA. All right, so like the session, I think the session will take, or like I think this part will be on two sessions, because I want to cover as much as possible about this part. All right, so first let's start with something simple. Let's start with the category, for example. So here we have our category entity. So as you can see, it's an entity, getter and setter, and so on and so forth. And here we have our base entity, and the category is a simple one with a name and description, and it has a relationship with games. All right, so like a category has a list of games, and a game has or belongs to a specific category. So what we will do, all right, so what we will do first, the first thing to enable Spring Data JPA is first we need to have this dependency among our in our pom.xml file. So this gives us the power of Spring Data JPA. So Spring Data JPA is a Spring Boot starter that gives us out of the box so many functionalities, like managing, like having the persistence manager, managing the transactions, like having everything out of the box, and among that, of course, being able to connect to the database through this configuration that we have right here. All right, so the first thing what we need to do is first we will create a Spring an interface, and let's call it category repository. So here we will, like what is offered by Spring Data JPA are repositories, and here all we need to do is to extend. So first we need to create an interface, not a class, and we need to extend some one of the interfaces. So here by default, like we can extend directly the Spring or like the JPA repository, which is the highest level. But if we go inside, so let's click on download source. By the way, this is a good habit. Always try to download source. I already mentioned that so many times. So download the source so you can see everything in clear. So as you can see here, the Spring or the JPA repository, first it's a parameterized interface. So it takes two parameters. First, it's the T, which is the entity or table, and ID, which is the ID type. All right. So as you can see here, so our category is of type, our JPA repository is for the entity category, and our entity category has an ID. So here it's a string. So this was the auto completion from IntelliJ. So I will change this one to a string. So we need the entity itself, and then we need the ID, or like the type for the ID of our entity. So here we know it from our base entity, which is of type string. So this will allow Spring Data JPA to correctly, or like to form the right queries to fetch the data, all right, or to manipulate the data, generally speaking. So now let's go to JPA repository. So we see that this is an interface which extends already to other interfaces. Among them, we have list CRUD repository, list paging and sorting repository, and query by example executor. So we will see, or like we will have a deep dive into the query by example executor, which is a feature that I like so much, and it helps a lot like writing or like fetching data in a good way. So here we have list CRUD repository, and this one, it already extends. So let's click again on download source. So this one also extends the CRUD repository or CRUD repository. So like CRUD is for create, read, update, and delete. So like the basic operations that we do on a database. And in here we see that we have a bunch of methods like save all, find all, find all by ID. Also, if we go a bit deeper, we have this CRUD repository which extends the repository interface. And here the repository interface is an empty interface, which is only to tell Spring or to tell Spring Data JPA that this is, or like any interface which is on this hierarchy is a repository interface. So Spring will automatically manage or like do a lot of stuff. So here in the CRUD repository, we see that we have the basic methods like save, save all, find by ID, exists by ID, find all by ID, and so forth. So like the delete and so forth. So again, if we go a level up, we have the list CRUD repository. So the CRUD repository, so here, like what I want to say before moving deeper. So here we extend JPA repository. So JPA repository, it comes with everything. But sometimes for some entities or for some applications, depends on the context, sometimes we do not need more than, for example, CRUD repository or list CRUD repository. So list CRUD repository, it extends already this CRUD repository, which comes with the basic methods, as I mentioned before. And here with this list CRUD repository, we have other methods like saving all, find all, or find all by ID. And by ID means that we can pass a list of IDs, and this will fetch the data like it will be select star from table name where IDs are in, or like where IDs in the list of IDs that we have in here. And as you can see, it takes as a parameter an iterable. An iterable can be an array, it can be an array list, or like it can be a list, generally speaking. And then we have our JPA repository, which is the highest level that contains everything that we need. So like including save and flash, save all and flash, delete in batch, and so forth. Again, what do we have? So we have list CRUD repository. And also we need, or sometimes we need something else. So we have list paging and sorting repository. So to improve the application performance, it's not recommended to fetch all the data that you have. So imagine that you have millions or like thousands or hundreds of thousands data, or like lines of data or rows of data in your database or in your table. And if you do find all, it will fetch everything from that table. And even if you do some paging or like some filtering inside in your code, so all this will be executed in memory, and this will take time and will also consume resources. So like time is money and resources is money also. So like this is something that we need to take care of. So here we have a list paging and sorting repository. So let's go inside this one. So this list paging and sorting repository, it has a find all method with a sort, like where we can pass a sorting. So like we can sort by an attribute and in ascending or descending way. Also, it extends this one, or like this list paging and sorting repository, it extends paging and sorting repository interface. So again, this one, it extends the repository interface, which is the latest, or like the first level of our repository hierarchy. So this paging and sorting repository, we can have it find all with a sorting and find all with a paging. And here a pageable, it's a simple interface where we can pass a size and a page, like the page number and the size of the page, and here it will return a page of result. All right, so we will see that also in deep. All right, so now for our case, just to make things simple, and we know that we want or like we need the paging, we need the sorting, we need all the operations. So that's why we are extending the JPA repository. But in some cases, or like in other cases, you might not need to extend direct JPA repository. So you can go inside and maybe pick one of these, like for example, extending list CRUD repository and or paging and sorting repository only. All right, but JPA repository comes with everything. All right, so this is the first thing. So now what also comes with Spring Data JPA, or like with the Spring Data JPA repositories. So here, as I mentioned, we have a bunch of methods, like we have a bunch of ready to use methods. So among these methods, as we mentioned, so we have the save method, we have the find all by ID, delete, and so forth. Also, there is something, or like for me, it's the power of Spring Data JPA. So here, let's imagine, or like let's assume that we want to fetch all the categories, or like one category by name, or a category that includes, for example, the name starts with something. All right, so here, like in a classic implementation, we would write a query for that, but Spring Data JPA comes with something really powerful. So here, let's say that we want to find a list of category. Let's import the list from here. So here, when we type find by, so find by or find all by. So find all by means that I want to fetch everything. So let's not care about the auto completion from IntelliJ. It might be distracting, but let's ignore it for now. So here we want to find all, and here if I type by, so here when I do find all by, I can in the first level filter by the attribute name. So I want to find all the categories by name. So here by, and then I need to type name. Here you need to know, or like you need to take to really take care about something. So here when you type the attribute name, after the by keyword, the name, or like the first letter of the attribute name should be in uppercase. So if I do find by name like this, so this will not work. So it should be in uppercase. So now let's say I want to find all the categories by name, and I want to find, for example, find all the categories by name, or like by name starting with. All right, so like this means I want to find all the categories where the name starts with let's say, for example, I don't know, like AC for action, or like for arcade, or something like that. All right, so something like this. So here what I can do, I can add starting with. All right, so here I can say starting with. So this will automatically translate or create behind the scenes. It will automatically generate the following query. So it will be select star. So like I'm writing the native query. So select star from category where name like. So here with a name like, something like that. So like, let's say, for example, I want to find all the categories where the name starts with A or with AC. So it will be A and then %. All right. So this means I want to fetch all the categories where the name starts with the letter A, or like with AB, AC, or something like that. So also there is something else. So here we know that we might have some categories starting with A uppercase and A lowercase, or like it might be all uppercase or all lowercase. And here we can also say ignore case. All right, so we can say also ignore case. So this means that it will be ignoring, like, or it will ignore the case. All right. So ignore case. So here all I need to do is to pass the string name, and here automatically Spring Data JPA will create this query behind the scenes. All right. So also, if assuming that I want to sort it in an ascendant way. So for example, I can say here order by let's say name, ask or desk, ascending or descending. Here I can add an order by name ask. All right, so this will order, or like this will add the following thing to our query. So this will fetch the list of categories where the name starts with the keyword, or like the parameter that we will pass in here, ignoring the case. So like if the category name is in uppercase or in lowercase, so it will be ignoring the case, so it will not be case sensitive. And it will order the list by name in an ascending order or descending order. So here, for example, if I want it to be descending, all I need to do is to type desk in here. All right. So now this is our first query, let's say. So this is the first query, and as you can see here, so maybe let's talk about the advantages and disadvantages. So the advantages, or like one of the main advantages of this, is I do not need to know about it, like I do not need to know a lot about SQL queries, which is okay. I do not recommend, to be honest. So knowing SQL queries, or like knowing SQL syntax, is really important, because sometimes we need to write some complex queries, so we need to write some SQL to fetch the data. So here all I need to do is to write a method, name that will fetch the data. So find all by name, starting with ignore case, order by name, descending, or ask, or like desk. So maybe let's bring it back to ask. So this is so simple, but the problem, as you can see, the first thing, the method name is too long. So this is very, very long. And imagine that we want to have a more complex query where we want to have some joins and all this stuff. So even the query name will be like a paragraph, which is something which pushes us, or like moves us to the next step, which is writing some queries, like writing the query itself. So like we need to write the query by ourselves. But before writing the query, so this is the first one. Now let's say, for example, I will go back here to my game entity, and I will create the repository. All right, so it will be an interface, and here I will create a game repository. So this one, again, it will extend JPA repository, and here it's gonna be a string. So now I have the power of Spring Data JPA for my game entity. So now let's say I want to find all the games belonging to a given category. All right. So here there are two ways. Let me explain things. We have two ways. We can get the category itself, and then from there we can get all the games, since the category has a list of games. Let me explain this one in a drawing. So what do we have here? We have our category entity. And our category entity, it has a list of games. So here we have games, and it's like one too many. All right. So we have two possibilities. The first one is to fetch the category by its ID. All right. So like get me the category with the ID 1, for example. And then I can, when I fetch my category, I know that I have a relationship between the category and the game. So I can do category.getGames. All right. So when I do fetch the games, it will, like Spring behind the scenes, it will automatically add the join, or like add the join query and fetch all the games for that given category. All right. So this is one way to do things. Or from the games here, from the games table, I want to find the game where the category ID, so like where cat ID equals something. All right. So this will fetch only the list of games. So like I do not need to fetch the category and then do the joining, but here I need to write a query for that. All right. So let's see how Spring Data JPA can do that for us. So I want to have a list of games. So here it will be list of games, and I want to do find all by category ID. So here I have two options. All right. So I have two options in here. So we know that in our game repository, we have a relationship with the category. All right. So here I can do only by category, and I can pass the category as So I can pass the category as a parameter in here. All right. So this will fetch the list of games by category. All right. So, and how to use this one. So here I will just write the code in here. So when I do, for example, so all right, maybe let's create a class in here just to make things easier. So we will need it later on. So we'll have a game service, and I will just give it the service annotation and the required args constructor. So the required args constructor, so by default it will create a constructor with all the final fields. All right. So when I do a final, so when I do here private final game repository, so automatically or behind the scenes, Lombok will create a constructor for me. So it will be in this way. All right, so like it will be something like that, and the condition to use the required args constructor is that my attribute or my field needs to be final right here, and then it will behind the scenes it will create something like that. All right, so here I will just do public void something, because we don't care about the name, and this is something we will delete later on. So now, as I mentioned, so here I want to get the list of games. So I will just do a var. Like, we will not be using var, but we will, for now I will just do it. So games, it will be games repository dot find by category. And here how to pass, or like how to do the joining between this find all by category, which takes a category object, not an ID. So we know that Spring Data JPA or Hibernate, it works with IDs. It does not work with the whole object. So here in a database, the relationships are with the IDs. All right. So like the relationships are with the IDs. So this is what creates the relationship in Spring Data JPA, or in the database generally speaking. All right. So here all I need to do is to create a category object. So here I have a category, new category, and I can say, for example, category.setID. And here, let's say, for example, this is my ID. All right. And of course, here we will have a string category ID, something like that. And I can set it in here. So like this is a readable code. So here, all I need to do is to pass the category as a parameter. All right. So this is one way of doing things, but as you can see here, I need to do some extra code in here. So I need to write some extra code. I need to create a category object, set the ID, and pass it. So here, even for example, even if I do category.set name and I give it, for example, blah blah blah, and then I have a description and so on and so forth, all this, so for example, all this will be ignored. All right, so like this will be totally ignored. So this will be ignored on the database level. All right. So why this will be ignored? Because as I mentioned before, in the database we only care about the ID. So this is the most important part for us, is the ID, because the relationships are with the IDs. And as you can see, or like just to remind you in here, when I have category, game, so I have colons and I have foreign keys, and as you can see, it's category ID referencing the category table and the ID colon. All right, so like it's not referencing any name or any other thing. All right, so this is one way of fetching the list of games by category using Spring Data JPA. So now also, let's say, so this will find all games by category. So I will say this is a V1. So like this is the first version. Now, instead, as I mentioned, instead of passing the category object itself, so as I mentioned, this one we don't need, but now I only want to fetch the categories by ID. All right. So here, what I can do, I can have a list of game and then find all by category, and then I can do ID. All right. So how to do that? So category ID is like this. Let me pass the parameter and let's say category ID. So we know that in our game entity, we have a relationship, or like we have an attribute called category. All right. So here we have category. So this is the field that I mentioned before. We need to type the field name starting with an uppercase. All right. And then since our category, or since this category object, or this category field is an object, so we can access its attributes. All right, so we can access the attributes of this category object. And among that, we know that we have an ID in our base entity. All right, so now coming back here, so category, and then in the same way, the field name of the category ID in an uppercase. All right, and all I need to do is to pass the parameter, which should match the same ID, or like the same type of my ID, which is of type string. All right, so this will fetch. So again, fetch all games by category ID. So here maybe, or like by category, I think this makes more sense. And this is the V2. All right. So now, assuming that I want to find, so in this way, now, like in this case, I do not need the category object. And here, all I need to do is category ID, and I pass the category ID, and it's done. All right, so the next thing, let's say, for example, I want to find all the games where the category name is something like that, or like equals something. All right, so here, let's say I want to find all the games where the name equals or is equals, for example, action. Let's say something like that. All right, so like I want to find all the action games, or like all the games belonging to the action category. So again, it will be a list of game. So here I have a list of game, and let's call it find all by category. And here I can access the name. All right, so here I can do find all by category name, and this will result in a query like that. So it will be select star from category, or here I will say just g.star, or like game.star, because I want to find all the games from category C, and inner join game G, for example, because like we gave it the alias G right here on G dot I think we called it cat or category ID or cat I, okay, category ID. So let's use the correct names. Equals C dot ID. So this is the first part of the query. All right. So then just going back to the line, or maybe let me do a block comment like this. So here where C dot name equals something, all right, equals action, for example. So this is the query or the result of this method name. So here again we come back to the power of Spring Data JPA. You see that with only a method name, just find all by category name, it will automatically create the query for us. So like with all the joining with everything. All right, so like select star from games, or like select G dot star from category C, inner join game G. So like this is an alias, so like you can give an alias to a table name. On G dot category ID equals C, or like my category dot ID, and here is my filter, so where the C dot name equals action, and all this results in a simple method name. All right, so this is one way of fetching the data, or like writing the data. So now, assuming that maybe if we come back in here, so like if we come back to this one. All right, so here, as you can see, sometimes we have an issue that the method name is too long. So how we can fix that? All right, how we can fix that? So let's say here I want to find a list of category, and let's say find all by name, for example. All right. So here find all by name, and I need to pass my or like the string in a game name or something like that. So this will result also like finding all by name, and this one will be ignored. So now I want to override this, and in order to write a query that will result in this one. So how to do that? We have an annotation, it's called query. All right, we have a query annotation. So let's have a look on it. So it has a value, count query, count projections, and so forth. So like it have a bunch of parameters, and all we need to do is to pass the value for that query. So the value is a string value. All right. So here we can use the string and like this one. So here all I need to do is to do select. So okay, let me do the following. So now we will be using the JPQL syntax. I will come to that. I will come to this just in a few moments. So here I want to find everything. So like I want to find C from category C. So like C. So here you see in JPQL syntax. So like JPA query language. So like this is this is what JPQL means. It's a JPA query language. So here, instead of having star and like having the table name and all this stuff, here we can just use the entity names. All right. So like this is the advantage of using JPQL. So why it's an advantage? Because here, for example, let's assume that I have a table annotation, name equals, let's say cat, or like maybe something like this. TBL cat with something blah 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 blah. So this, like, trust me, this is something that you will find in some real world projects, especially in the banking area. So like you will have an entity, like the logic name is category, but the database table name is something completely different. So coming back to this here, when using the JPQL syntax, all I need to do, or like I need to manage or like to manipulate the entity name. The entity, I mean the Java class name. But when we want to work with native SQL queries, we need to work with the table name itself. All right. So for now, I will just like delete this, and we will see it in a few moments. Like we will see the native query part. All right. So now I have my query in here. So select C from category, and here let's add the where clause. So okay, so like this is the auto completion. I don't want it to be this way. Okay, we said, okay, for now let's keep it simple. Just name right here. All right, so now what I want to do, just select everything from category where the name equals my name. All right, so now I want to add some filters, or like I want to do, for example, this order by. Here all I need to do is order by C dot name, and then I have ask or desk or any, like the sorting order, or like the sorting I want to have. All right, so here I just transformed this method name into a query in here. So like my query is readable, my query looks nice, it does everything that I need. Also, if I need, for example, some lowercase, I guess we have here lower of name. So like this is part of the JPQL. So this lower is a method. So I can use lower, so just to be compliant with this one. So I want all the games with the name lowercase. So like I just want to ignore the case, and then I want to order it by name ask. All right, or like order by any other field or any other column is totally fine. So this is the JPQL syntax. All right. So here, as I mentioned, so in case we have or like our method will result in a very long name. So we have also the alternative or the option to use the query annotation. there is something else interesting about queries. So here we see that we have name and here we have name. So if we have the same parameter, so like a parameter is a colon and then the parameter name. So this is how we pass a parameter to a query. So now if I want to have something different, so here let's say, or like also we can do it this way, by the way. So like question mark and then the index of the parameter. So it will automatically result this one will be mapped to this one. So like we have two options, but using named parameters is much better and easier to read in case we have, or like we want to write a query with multiple filtering or with multiple parameters passed to the query. So now assuming that here my parameter here in my Java code is called category name, for example, and I want to keep my query like this. So here we have an issue. Spring Data JPA will not be able to map this one to this parameter, all right, because they do not have the same name. If both of them, they have the same name, so this is perfectly fine, all right? But if they do not have the same name, Spring Data JPA will not be able to know or like to understand that this one is meant for this one. So the solution in here, so whether we can use this syntax, so this works, or there is something better. So here we have an annotation called param, and this param, all we need to do to give it a name, or like, so this name should be the same as this one, and then later on this name or like this parameter will be mapped to this one, all right? So Spring Data JPA will know that this parameter in the query is called name, so here or like maybe let's call it this way just to make the difference, all right? So like I will call it cat name. So Spring Data JPA will know that this category name has a name inside the query called cat name, which is this one, and then Spring Data JPA will be able to map it to the correct parameter inside the query. So this is something also worth, or like you need to know. All right, so this is the first thing, and this is our JPQL syntax. And by the way, the JPQL syntax is really close to the normal syntax. So now let's go back to the game service and let's try to game repository, and let's try to find to write or like to rewrite this query using JPQL. So again, it will be a list of game, and here let's say find all by cat, just to have a different name, and here let's say cat name, for example. So now again I will use my query annotation. So let me format. So it will be select G from game G. So this will be my alias. So like the G is an alias for the game. Now I need to do some joining between the game and the category, because I want to find all the games by category. So here all I need to do is to do inner join. And here we have two options, by the way. So here we can do inner join g.category C. So like I want to join my game object to the category object, or like my game entity to the category entity. So like this is one valid way. Or also I can do this way. So join category C and then on g.category g.category.id equals c.id. All right, maybe I keep it in the same line. So this is the joining. So like this is the joining that we did in here. All right, so here, because we are using the JPQL syntax, so here JPQL syntax, so here we have like in the database, or like in the real database, we have g.category ID, but in JPQL, in the game entity, we do not directly have an attribute called category ID, but we have an attribute called category, and inside the category we have access, or like we can access the ID. So this is why in here when we do the joining, so like we are joining category C on g.category.id equals c.id. So like we need to write it this way. So now let's add our filter. So where name g.name equals something. All right. So like, but here we want the category.name. All right. So here, let's say like percent or like cat name. And again, we can use the param in here. So we have the param and let's call it cat name. And in this way, we are able to write some joining. So like in this way, we can write more like really complex queries. So this is the first thing. I will just duplicate this one, comment this out. So code comment with block comment, and I just here just to keep it for record. And here for the joining, I will not just directly access the category or like have any category. I will just do join game.category, and that's it. So like when I do join g.category, behind the scenes it will do the same thing as we did in here. All right. So like later on, we can also, when we run it, we can also display the query, and we will see the result or like the output query of this one. So this is also another way of do the joining. Again, we can do like other joining. If we have a more complex query, we can do all the joinings that we need. So this is one way of doing things. Now let's see if like, or in case we want to fetch the data using a native SQL query. So native SQL queries is going to be something like this, for example. So let's go to the category repository, and here let's rewrite this method, but using a native SQL query. All right. So again, it will be a list of category. So find all by name native, just so here by name using native query. And now all I need to do is to have my query annotation. And now I will give the value. And here after the query, there is an attribute, sorry, not modifying, but it's just query. I don't know why it's like this. And here we have a native query attribute. So like we have a parameter called native query. By default, it's false. And as you can see, it's the default value. But when we set it to true, so this means that Hibernate will directly execute this query. And then I will tell you the difference between using JPQL syntax and using a native query syntax. All right, so here let's maybe write it, write a simple one. So which is select star from, select star from category. So here we don't need to, or like we don't need to write the entity name with an uppercase, because here we need the table name. All right. So here, in this case, we need the table name. Maybe let me use it this way. All right. So select star from category where name like this one. For example, let's say cat name, and then order by name ask. So this is a simple query. All right. So here, all I need to do is to mention in the query annotation that my query is native. I will just break the line. So all I need to do is to mention that my query is a native query. So Spring Data GPA will just pick this query and execute it and try to fetch the data using this one. All right. And again, we still have the power of using the named parameters like this one. So like this still valid, because this is something that belongs to Spring Data JPA. But the text or the string that we have in here is up to you to write the correct query and like to take care of the syntax and all this stuff. All right. So now let's see the difference, or like the advantages and disadvantages of using this one over this one. So the first thing, or like the first main difference, is when using a query using the JPQL syntax, So we have the advantage that the query will be validated at the starting up, or like when we start up the application. So like at the not the runtime, but the startup time. All right. So when we try to start the application, Spring Data GPA will validate the query that we have right here. So for example, if we type something like this, okay, so now here we know that IntelliJ will try to highlight, but we can still run the code, by the way. But if you are using another IDE, maybe you will not see the difference, or like you will not see this compilation error because the IDE will not highlight it. So when we start up the application, Hibernate, or like Spring Data GPA, will try to validate and see if this query is correct or not, and to see if we have all the attributes and if this query can be executed later on or not. All right. So this is the first thing. Second, for some database management systems, for example, if you are using, I don't know, like any other SGBD or like any other DBMS, maybe you do not have this maybe you will not have this lower method. So like as you can see here, well, I think from my side, or like from my case, I do not remember which method is used for Postgres SQL. I think it's lower again. Yeah, I think it's lower of this one. Yeah. So with Postgres SQL, I guess we have already the method to use, or like to transform a parameter or a value to a lowercase. But maybe this syntax, or like using the lower, maybe let's keep it in here. So for Postgres SQL, it might be lower, but for example, using Oracle or Microsoft SQL Server or MySQL or something like that, the syntax is not the same. So here, when using a native query, you need to take care of that by yourself. But when using JPQL syntax, all you need to do is to use these functions from the JPQL syntax, and then Hibernate will transform this method to the correct one for that DBMS, or like for the database management system tool that you are using. So this is the first advantage. The second one here, like we lose something. So like here we are managing, like when we talk about the native queries, we are managing, or like we are handling the tables. All right. So assuming here, as I mentioned before, so we have our table annotation, and we have a name, which is something like this: table cat, blah, 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 blah. So you need to use this table name instead of using category. So like it needs to be this way, right? So you need to know the table name. You need also like to map it, of course, in here, like to have the annotation if the table name is different. So you need to work with the table name directly instead of working with the object, or like with the Java object itself. All right. Also here we have a name. Then on the database side, the name might be something different. So here, let's say colon name, and let's say, for example, it's something like this: table cat call name. I know this is weird, but I'm just trying to to show the difference. So like the column name in the database, it might be something like that. All right. So here, instead of using name, I need to use this one. All right. So and now I guess you start to see what I want to say. So here, using a native query, it's okay, it's good, but you need to manage, or like you need to handle the names, or you need to handle the database tables instead of playing or like working with the entities, with the entity itself, which is the Java class. All right. Also, you will lose the advantage of using some of the methods that are provided by JPQL, which like where JPQL later on will try to translate it to the correct one. All right. So this is one way of doing things. All right. So for now, I will keep this, and then we will clean up the code when we move to the next part. All right. So now we have we tried almost to cover so many things. And now let's say that I want to update, or like to have to change the state of something. So for example, we know here from our design resources and game store. We know here from our database design, we have something, or we have, for example, game request. All right, so like we have a game request. And here in this game request, for example, I want to do a bulk update. A bulk update means that I want to change so many lines at the same time. So I need to write a query, or like I need to write the code to update all the game, or like all the lines in here. Or even let's say I want to do something else. I want, for example, from time to time, or like for games from time to time, I want to update all the names of the games and to put them into uppercase, for example, or to transform them to a lowercase value. So the way to do that is the following, for example. So here, let's say a public void something else. So what this means. So for example, how to do that? Like maybe because this is I saw this code from many students and from many people. So what to do exactly? So for example, let's say I have a list of game. Let's import this and let's call it games equals repository dot find all. So what they do games dot for each, or like for each game inside into games. Let's say for example game dot set title, for example, and here let's say game dot get title. Sorry, I do not this one. Dot to uppercase. All right, so to uppercase, and then we do game repository dot save game. So here you see first that we are fetching all the games from the database, then applying a transformation, and then saving the game. Or like we can just update everything, and then we can do, for example, game repository dot save all. So like it's the same, by the way, save all games. All right. So this is one way of doing things, but we can just do this in one line. All right, in one line of code. And how to do that? So let's go to our game repository. So here I want to have a public void, for example, transform games title to uppercase. All right. So like I want to transform everything. All right. So like I do not have a filter for that. So here, what I need to do, I need to type my query. So here, let's say my query is the following. So it will be update game and then set title equals upper of title. And this is my query. All right. And then all I need to do is from my game repository, I do game repository dot update, or like transform game title to uppercase. So first I get rid of all this code, like fetching the data. So like I have a first query or like a first transaction with the database to fetch everything. I have a for loop to update everything, and then I need to have, or like to every time to send the query to the database to save the games, or like the list of games. Imagine that we have thousands of games. So like fetching thousands of games, storing them in the memory, and then updating each one of them, and then having like thousands of transactions to the database to update all that. Or I can do all that in one line. But here we have something missing, because this query annotation is for fetching the data. All right, so like for fetching the data. And here, as you can see in the documentation, so like annotation to declare finder queries directly on repository query methods. When using a native query variant is available. So also like instead of, by the way, so this means what? This means, I guess it's in the category. So like this means instead of using a query with the native attribute equals true, we also have a native query, a native query annotation. So we can use it also this way directly. All right. So like we have two options. Right, so maybe let's keep this one as a native query. Let's go back to here. We can also see the modifying and native query. So modifying what this does. So here, for example, in case we want to update or delete, all right, so like in case we want to update or delete something, we can use, or like we need to use the modifying annotation. So here I need to add modifying. So here modifying means what? Indicates a query method should be considered as modifying query as that changes the way it needs to be executed. So this annotation is only considered if used in a query method defined through a query annotation. All right. So when you have a method having this query annotation, and then if you want to update or like to do or to execute an update query, you need to add this modifying annotation. So an update query is whether an update or delete, update, insert, or delete. So like these are the three modifying queries. So having only this one without the modifying, this will result in an error. So we need to add the modifying annotation. All right. So now, as you can see in here, is with just one simple line, I can do a lot of things. So like instead of having so many transactions into the database, I just need one line to update everything in a single query with a single transaction. So here, of course, you need to be careful when updating or deleting something. If you need to add the where clause, for example, let's say, for example, I want to update everything where title like something, all right, or like maybe the title starts with something else or something like that. Maybe let's remove this for now. All right. So now this is what is named modifying query. The next topic I want to talk about is named queries. And before going into named queries, we see in here that for each query I need to write the query in here and then pass it in here and so on and so forth. But we can use something which is a bit more elegant, and it will look nicer. So what we need to do, so like now we will see the named queries. I will keep this code in here, by the way, just to keep it as a reference. And then, as I mentioned, I will push it when we finish this today's session, and then I will clean it up so you can keep it, or like you can see it in the history of commits of this session. All right. So now we will talk about named queries. I will close other tabs, maybe leaving this one. So first, what is a named query? So a named query in Spring Data GPA are a predefined queries that are associated within an entity, and they are defined using the named query annotation. All right. So first, let me clean this up. So we don't need this one. It was just an example. And now I can define my named query in this way. I need to give it a name and a query. All right. So we will come back to the implementation in a few moments. So these queries are given first, as I mentioned, they need to have a unique name. All right. So like we need to give it a unique name. So generally, or like by definition, we define the query names, or like the named query names, in this way. First is the entity name or the table name. So category, and then dot the query name that you want to give it to it. So for example, let's say find by name, something like that. All right. So this means that I want to find the category by name. All right. So now before moving to the implementation, let's talk about some advantages and disadvantages. Well, there are no disadvantages actually, but we will talk about some advantages of using named queries. But first, before moving to that, let me first try or like write our first example. So let's go to our category repository and just copy one. So I will copy this, for example, and I will paste it in here. I'm gonna break the line and just to format the code. All right, so this is my query. Okay, so here we have a named query with a name, that the name that should be unique, and the query itself. Also, we have, in the same way, we have native named query, or I think it's called named query native. Named native query. So like it's also the same, just we need to give it a name, and also we need to give it a query to be executed. All right, so let's go back to our named query. So first we declare the named query on the entity level. So this is the first condition. So like on the entity, all I need to do is to add this named query annotation, and we can add an infinity of them. All right, so like I can have also another named query, and with a name, for example, something, and the query is something. All right, so like I can have an infinity of named queries. So now how to execute, or like how to run this named query, or like how to access the data using this named query. So now I will do, for example, a list again, and here find all by named query. So here we have a parameter. All right, so we have a parameter called category name. All right, so here let's say category name, and here again I just need to use the query annotation, and now instead of a value, all I need to do is to pass the name of the named query that I want to execute. So it will be something like this. So I will copy this one and paste it in here, and that's it. All right, so this will automatically try to execute, or like try to find a named query called category.findByName on the category entity level. All right, and also let's not forget the param in here. So like everything, or like the rest, remains the same. So here I think we call it cat name. Yes. So the rest remains the same. So now I would like to talk to you about the advantages of using named queries. All right. So some of the advantages. First, it improves the readability and maintainability of the code. So by defining queries in a central location, like a central location, I mean by this the category itself, or like the category entity itself. So like in a class, or even like an XML file, we can also do that. So like named queries make it easier to manage complex queries and reduce duplication in code. So in case I would like to execute this one many times, or like in a different places, all I need to do is to declare it in one place and then use it in different places. Also, like this is about reusability, like named queries can be reused across multiple methods or parts of an application, like promoting the dry principle. Like the dry is do not repeat yourself. So like I think, I don't know if you heard about this term or not, which is this one. Oops, maybe let me write it, which is dry. So dry is do not repeat yourself, or like don't repeat yourself. Just write it once, use it many times. All right, also it has some performance optimization. So like this is also important. Like named queries are parsed and compiled during the application startup. So like this is the important thing. So like it's parsed and compiled during the application startup, which can improve performance as the query preparation phase is completed ahead of runtime. All right, so like the preparation of the query, or like fetching the data using named query, is already prepared ahead of time. All right, also it has another advantage, which is decoupling query logic. So like separating query definitions from application logic promotes a cleaner architecture by isolating query logic in entities, or like into entities files. All right. Also, we have another advantage, which is error detection at startup. So since the named queries are validated, when the persistent context is initialized, so the syntax errors in queries can be detected early to avoid runtime issues. So like, because we have these queries will be checked ahead of time. So this will help us avoid errors, or like it will help us for detecting errors at startup. All right. So we have a support for parameterized queries. So the named queries, they support parameters, reducing the risk of SQL injection and simplifying query execution with dynamic inputs. All right. And of course, all this is available when we use Spring Data JPA, and like this named queries is part of the Jakarta, or like the Jakarta persistence layer, which is the specification and the implementation that we are, like the first implementation that Spring Data JPA uses is the Hibernate implementation for that. So like this is the name, like using the named queries is so simple, is really simple. All we need to do is to have this named query annotation with a name, a unique name, and also with the query itself. And when I want to use it, all I need to do is to use query and then just give it the name. So here, as you can see, the named query to be used. If not applicable, if not defined, a Jakarta persistent named query with a name domain class.query method will be used. All right. So this means what? This means because this is very important. All right. So here I give it a name, or I can, for example, like I want to execute this query. Find by name. All right, so here I would just call it this way: named query find by name. All right. So now, in order to use this named query, I have two options. So the first one, using the query annotation, and I give it a name. All right, so I need to give it a name. So the name should be the native the named query name. So like named query find by name. All right. Or if I do not provide a name, so if I choose to do the following, just the query annotation, but the query annotation is needed when I want to execute a named query. All right. So here, if the name is not provided, so the combination, or like how the name is created. So it's domain class, which is category entity in this case, dot query method name. All right. So like it will be category dot this method name. So I need to change if I change, so yeah. So if I change the name of my method to this one, and I use the query annotation, and if I do not provide the name, so here I will not provide the name. So automatically Jakarta, or like the persistence layer, will try to find a named query called category.query method name, which is this one, named query find by name. All right. So like this is also another way to use, or like to try to execute a named query. But in case we do not find the named query, like it will result, of course, in an error when we try to start up the application, or when we try to execute this method. All right. So like we have two options in here. So this is very important, because you have two options to call a named query, whether you give the method the same name as the named query in here, or use the name attribute. All right. Or use the name attribute. So here it's category dot named query find by name. All right. So this is about the named query. Also, there is something else. So in case I have so many named queries, so that we can use the annotation named queries, but I think this one we can. So because this one, like we do not need, because named queries is just a wrapper. So here like SonarQube is saying that this wrapper is not needed. So we just can use named query directly without named query. So like named queries, you can consider it as a list of named queries. So here it's an annotation named queries, and inside it we have the list of named queries. So it's up to you which one, or like which option you want to use, like whether having named queries one after the other, or having named queries annotation, and then we have a list in here, and then we have, or like we declare the different named queries annotations, like with the annotation named query. All right, so for today, I guess this is the first part that I wanted to start with in Spring Data JPA. The next time, or like the next part, we will start, or like we will have a deep like another dive into Spring Data JPA, but we will see something else. So like we spoke already about the query by example executor, so we will see that. We will see the paging, we will see the sorting. Also, like this query by example executor is very important, so I want to cover it really in a good way. And also, like we will see the paging and sorting, how to fetch the data, or like how to paginate data and sort them, and so on and so forth. So I will be waiting now for your questions, and I will move on to the chat in few moments. So prepare your questions, and I will try to answer all your questions for today's session. But before that, let me push the code, or like the changes we did today. All right. So let's say session 6, Spring Data JPA, and in here we saw repositories, JPQL queries, native queries, and named queries. All right, so go ahead, guys, and ask your questions, and I would answer all your questions about today's session. right, I see some questions. So first, let's start with the first one. So like, which solution is better for performance, going with native queries or those JPA predefined methods? So for performance, this is a good question. So like, maybe sometimes for some complex queries, it's better to go with native queries, just to be able to formulate the query the way you want. Or like performance wise, I think using JPQL syntax is better for performance. So it really depends on the use case. So can we have multiple named queries, one after other, right, like multiple times? Yes, exactly. So this is what I mentioned. Like all you need to do is to have the named query annotation multiple times with the query name and the query itself. All right. So next question regarding the JPA specification. Can you tell us a bit about it? Is it a good practice to use it? And what are its advantages and disadvantages? So it's a good question. The JPA specification, we will cover it also next time in the next session. So we'll see the query executor, or like the query by example executor, and we will see the specification. Like we will cover everything. All right. So like we will cover everything in the next sessions. Do you have any other questions? Also, like specification is really an interesting topic. So we'll see it also in details, and it really makes life so much easy. So we will cover it in details. Do you have any other questions? Or even like a feedback about today's session? Was it good? Did you learn something new? Like just a global feedback. All right, guys. So if you do not have any further question, thank you so much for joining today. It was, as always, a pleasure having you, and see you next time. Thank you so much, and see you in the next session. All right. So maybe before, okay, we have another question. Isn't it cumbersome to have several named queries in the model? I would say yes and no at the same time. So okay, so when we have complex queries, or like I already gave you the advantages of using named queries. So like why we use named queries. So like mainly it's for organizing the code and reusing the code, and like using the dry principle. All right. But sometimes, as you mentioned, it might be a cumbersome, or having so many named queries to fetch the data. So like it's up to you to choose, like whether using named queries or extract them to the JPA or like the repository layer. So it's really up to you. All right. So when or how many week you planning to overend JPA? So to be honest, as I mentioned before, or like before we start the bootcamp, so for me, it's not about how many sessions, or like when we end this, or like when we start that, but when I see that I covered all the topics that I want to show you, and all the topics that I want to teach you, for me, I will say, okay, it's fine. Like even if I forget something, I can also cover it in like in another session. So like the sessions, I try of course like to put some titles when we start the session, but I would like to give you as much information as I can. I would like to share as much details as I can. So yeah, this is honestly my answer for this one. So like I do not have a specific planning to or like for like how many sessions for Spring Data JPA, or like how many sessions for this and that. And yeah, this is how it is. All right, so nice session. Thank you so much. Thank you for the feedback. So yeah, okay, so if you do not have any further questions, thank you so much for being here today, and see you in the next one. Have a nice weekend, have a nice new year, and see you in the next time.